Hey guys, this is Miss Dupe, and today we are going to start talking about our exponent rules. So the first rule we're going to be talking about is the product rule. Our goals for product rule is that you will understand, explain, and apply the properties of exponents or exponent rules to generate equivalent expressions. You will understand bases must be the same before exponents can be added, subtracted, or multiplied, and you will understand exponents are added when bases are multiplied. So today we are going to talk about this product of powers, but I mostly refer to this as the product rule just because it's less of a mouthful. So the rule is to multiply powers of the same base, you add their exponents. So once again, I know we already talked about this, but our base is the larger number and our exponent is the number that's kind of up above our base and smaller. So some examples of product rule. This first one, we have base 2 to the fourth and base 2 to the third power. Since those bases are both 2, we can use our product rule to add our exponents 4 and 3, and so our equivalent expression is 2 to the 7th. The general rule is written here with our variables. So if we have base a to the m times a to the n, you can combine those bases a and add the two exponents. So now we're going to practice it on our own. So in number 1, we have both base 3, and those bases are being multiplied. So we can go ahead and combine both of those base 3's into one base 3, and then add our two exponents, which our exponents are 2 and 4. So our final answer would just be adding those exponents together, which 2 plus 4 is 6. So 3 to the 6th is our simplified answer written with our exponent there. So the next example, we have base 5 and 5, and they're being multiplied together. So we're going to combine those bases into one base 5, and then our exponents are 5 to the second, 5 to the first, so 2 and 1. And since we're multiplying those bases, we're going to add those exponents. So our final answer is going to be 5 to the 2 plus 1, which is 3. Our next example, we have base 9's, and they're being multiplied together. So since they're both the same base, we're going to combine those into one base 9. And then our exponents are 3 and 2. So we're going to have exponents 3 plus 2. So our final answer is 9 to the 5th power. Now we can also have variable bases. So in number 4, we have base c to the 3rd times base c to the 5th. So we're going to combine both of those like bases into one base c. And then we're going to add those exponents 3 and 5. So our final answer is going to be c to the 8th power. Our last example on this page, number 5, shows that we have base a to the 3rd times a to the 2nd. So again, we're combining those two base a's into one. We are adding our exponents, 3 plus 2. So our final answer is going to be a to the 5th. So now we're going to go to the next page and view more complicated examples. So in these examples, we have what's called a coefficient, a base, and an exponent. So to break it down a little bit, this example right here, this first term that's shown is negative 3x squared. Negative 3 is our coefficient. X is our base because x is holding up our exponent 2. So that's a lot of vocab that we have here. So I'm going to actually take this off of the problem again. So when we have numbers and variables, we always work with the numbers first and then we work with the variables. So in this example, we have negative 3x squared times 4x to the fifth. The bases are the same because our bases are x. So we will actually multiply those coefficients, those numbers first that are on the front. So we did negative 3 times 4, which gets us this negative 12 here. Then we focus on combining our bases, our x's. So we combined our x's into 1. That's how we got down here. And then all we have to do is add our exponents. So we should be getting negative 12x to the 7th as our final answer. So to practice one together, this is also multiplication. It's just written with the parentheses multiplication instead of with the dot like above. So the first thing we're going to do is multiply our numbers. So our numbers are negative 2 and negative 8. If you need to use your calculator, use it. There is no shame, I promise. So negative 2 times negative 8 gets us a positive 16. Now, we still have that m to the first that was on negative 2, and we have that m to the fifth that was on negative 8. So now we are going to work on adding those exponents. So this is the same thing as 16. We're going to combine our m's together, m to the 1 plus 5. We're going to add our exponents since we're doing the product rule. So now down below, we're going to add our exponents, 16m to the 6th. And in fact, that is our final answer. Kind of did that one a little wonky. So we are going to continue and do 2 more examples just to make sure we're really clear how to do this. So we are going to do this problem, negative 5d to the 6th times 8d to the 6th. So once again, the first thing you want to do is multiply those coefficients right here. So negative 5 times 8 would be negative 40. Then we are multiplying and we have 2 of the same bases, d and d. So we're going to combine those into one base d. And then we are going to deal with our exponents. We have 6 and 6. Since we're doing the product rule, we are actually going to add those exponents. And then for our final answer, we just need to add our exponents. So we have negative 40 d to the 12th power. Our last one we're going to do is kind of a special case that shows our invisible math. So we are going to do 3x times 4x to the 4th power. So let's just start out by multiplying our coefficients here. So 3 times 4 is 12. Our bases are both x, so we are allowed to combine them into 1. Now, it appears we only have one exponent, which is our exponent of 4 here, but there's really nothing on the 3x. However, invisible math tells us that when we don't have an exponent there, it's actually secretly an exponent of 1. So we are going to add our exponent 1 plus our exponent 4, which gets us a final answer of 12x to the 5th power. So I lied, we actually have one more that we're going to do, which is one where we have multiple variables and bases that we're working with. So this one is going to be 3m cubed n squared times 8m n to the 3rd. So first of all, just like in the last problem, we do have some invisible math here, which is on our m that's inside the parentheses. Since there is no exponent on the m, it is actually an exponent of 1. So I'm just going to go ahead and mark that right now. Now the first thing we do with product rule is we are going to multiply our numbers in front. So 3 times 8, which is 24. Then we are just going to work with each variable individually. So we have an m and an m. So we're going to combine those into one base m, and then we are going to add our exponents. So we have 3 plus 1, which would be to the 4th power. Next we have our base n's. So we have n and n here, so we're going to combine those into one base n, and then we are going to add our exponents 2 and 3, which is 5. So our final answer is this 24 m to the 4th n to the 5th power. One more thing I would like to discuss. Say we have a variable that does not match the others, which this will occur in your practice. If you have a variable that does not match, let's say we have 2m squared c cubed times 4m squared. The only thing you do is multiply your front numbers like normal, combine your m's together and add the exponents, and then this c right here, since it doesn't match up with anything on the other side, you just bring c cubed down with your answer. And that is it.